Hello, today I'll explain to you the right hand rule and I'll try to solve as many exercises as I can. But first let us agree on how we will deal with the directions. When you draw an arrow up, that means it's upward in the plane of the paper. It's going to the top of the paper. When you draw an arrow down, it's going to the bottom of the page. Arrow to the right means the direction is to the right, arrow to the left means direction to the left. Dot means it's out of the page, as if it's going out of the page going to the roof, okay? And cross is like into the page, as if it's going through the paper into the ground, alright? And sometimes also it's demonstrated this dot as out of the page and this cross as into the page. Alright, now in our solutions we're going to assume conventional current. Alright, just to keep that in mind. Now let us assume here that we have a wire with a current going upward. You see the arrow up here? This current is going upward in the plane of the page. Now we're trying to explain now the first right hand rule. To learn this really easily, just what you need to do here, your thumb will demonstrate the direction of the current, your curled fingers around the wire will demonstrate the direction of the magnetic field. Okay, so in this situation your thumb should be aligning with the current. So as you can see, our curved fingers here, I'll try to align my thumb with the direction of the current. Again, I noticed that on the right of the wire, my curled fingers point into the page, and when I turn around and grab this round, on the left of the wire, my curled finger point out of the page. Okay, so on the right side of this wire they're going into the page, on the left side they're going out of the page, as if I'm holding this pen here. Okay, my thumb is going up. If I just like notice how on the left they're going out of the page, on the right into the page. Okay, so this is the first right hand rule. Your thumb will follow the current, your curled finger will tell you the direction of the magnetic field. So on this side here, the magnetic field is going into the page, so it's a cross. On the left side, it's a dot out of the page. Okay, and the picture here on the right shows you how you grab your the wire with your thumb, as if you're grabbing the pen, for example, to illustrate how the current will go. Now let's assume another example here. Let's suppose we have a wire and the current is going downward this time. So in this case, if I allow my right hand with my thumb going down, I notice that on the left side of this wire, my curled fingers point into the page. If I curl my fingers around, on the right side of this wire, my fingers are out of the page. So on this side here, it's out of the page. The magnetic field is out of the page. On the left side is into the page. So that's the first right hand rule. For the second right hand rule, in this case you will use your thumb to point toward the north of the magnetic field, and your curled fingers will follow the current. Okay, so what you will do is you will bring your pen. Okay, let's suppose here we have a current, as you can see in the example. We have a current coming here and then curling around the loop and then going down on the left side here. So I'll just hold the pen in a position just above the figure that I have, and I'll try to curl my fingers in the same way the current is going. And as I can see here, from the front side of the coil, the current is going up, and from the back side it's going down. So if you try to follow that with your right hand, you will notice that from the front side of the pen here, I'm going up, and then from the back side I'm going down. So now I'm going with the same way the current is going. Okay, and I notice that my thumb is pointing to the left, and I can deduce from that that this side here is the north and here is the south. Okay. Now the third right hand rule. Okay, the third right hand rule is used to determine either the velocity, direction of the velocity, or direction of the magnetic field, or direction of the magnetic force. Okay, now if you look at the picture here, if you follow what's in the picture, the thumb will go in the direction of either the velocity of the charge or the direction of the conventional current. Okay, so your thumb, if you have a current carrying wire, it will point in the direction of the current. If you have a charge moving, your thumb will go with the same direction of motion of the charge. The four fingers will point in the direction of the magnetic field, and the force for a positive charge, it's going out of the palm. Okay, if it's a negative charge, out from the back of the hand. Okay, again, the thumb for the direction of motion of the charge or the direction of the current, the four fingers in the direction of the magnetic field, and the force for a positive charge is coming out of the palm, as if it's going out of the palm, and for a negative charge going out of the back of the hand. Okay. Now we're asking here, first for question 1, we'll just know how to draw the magnetic field. Simply it's going from north to south, and then coming into the south, and then going out of the north, and here as well from north to south. Okay. Now, inside the magnet, it's just like going from south to north. On the outside, from north to south. Okay. All right. Now, for the current carrying wire here, they're asking us to find the magnetic field. So let's apply the right hand rule. The current here is going to the right, so my thumb should point to the right. I curl my fingers, and you notice that above the wire, if I put my hand, again, my thumb is going with the direction of the current. I curl my fingers, so above the wire, my fingers are pointing out of the page. If I curl my hand around this wire, below the wire, my fingers are pointing into the page. Okay, so just imagine that we have your thumb going to the right. If I put my hand like this, above the wire, my fingers are pointing out of the page. Below the wire, if I curl my hand, are pointing into the page. So above the wire here, we're out of the page, so B is dot. Below the wire, it's cross. Okay. All right. So for these questions, we have a current carrying wire. All right, and we'll assume those four arrows here point in the direction of the magnetic field, and the arrow here points in the direction of the current. The four arrows here point in the direction of the magnetic field, and this is for the current, the bold arrow. We'll assume here that the current is coming to the right. We'll assume here that the current is also going to the right. Okay, this is for the magnetic field, the cross here for the magnetic field. So as we just learned, the thumb for the direction of the current, the four fingers for the direction of the magnetic field, the palm. Okay, so I'll place my four fingers in the direction of the magnetic field. They're pointing to the right, so my four fingers to the right. My thumb in the direction of the current, it should point upward. And so I noticed that my palm, so my forefinger, the magnetic field to the right, the thumb is up, and I noticed that my palm is pointing into the page, like going toward the ground. And so the magnetic force here, F, in this first question, F is into the page, so it's a cross. Okay, now here the current and the magnetic field are parallel, so no magnetic force. We know that if the direction of motion of the charge or the direction of the current is parallel to magnetic field, so no magnetic force there. Now B is into the page. This question here, 14. B is into the page, the current is to the right, so my four fingers should point into the page. So this is going like as if it's going into the page. My thumb, which is the current, is pointing to the right. As you can see here how I place my hand. Okay, so the four fingers onto the page, my thumb to the right, and so my palm, which is on this side, is pointing toward the top of the page, so upward. It's pointing upward, and so the force here is upward. Now for the question 15, B is downward and the current is to the right, so I'll put my fingers downward, the current to the right, and so I notice that my palm is into the page here in this case, so F is cross into the page. Okay. Now the arrows and the dots and the crosses, will assume those are for the magnetic fields. Okay, so this is for B, 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 this is for B. Now the cross and the dot here on the bold arrows are for the current, so this is I, and I. We're looking for the magnetic force here. So I is dot, means it's out of the page, so my thumb should point out of the page toward the roof. B is downward, so I'm gonna twist my hand a little bit, so B is downward, my thumb is out to the roof, and so I notice my palm is pointing to the right. In this case, so force is to the right in this question. Now, for the second question, I is into the page, so my thumb should point toward the ground into the page. B is down, and so I notice that my palm is pointing to the left, so F to the left. Now, in question 18, B is into the page, my four fingers should point into the page. Okay, and the current is out of the page. Oh, in this case, current and magnetic field are parallel, so no magnetic force. Is upward. Now B is to the right, I is into the page. Okay, so my thumb into the page, B to the left, my thumb, that's the current, into the page, B to the left, the palm seems to be pointing upward. That's the magnetic force. B is out of the page. The current is it has a component to the right and a component upward, but it's eventually to the right, so the force will be eventually in this direction, perpendicular to the current. So it's gonna be this way. Okay. Now in the following questions, we're going to talk about charges, where the arrow that is connected to the charge here is the direction of motion of the charge, and the multiple arrows here is for the magnetic field. So this is for B, this is for V, and so this is for V, and the multiple dots crosses here for the magnetic field B. Now as you can see here, they decided to give us this key that if it's an empty circle, so that's a positive charge. So assuming this is a positive charge, okay, and if it's a black dot, then that's a negative charge. Okay, so let's go ahead. Now my thumb will point in the direction the charge is moving. My four fingers will point in the direction of the magnetic field. So magnetic field to the right, my thumb upward. You can notice that my hand is going to be this way. So my four fingers to the right, my thumb up. So I notice that palm is going into the page. Now here we have a positive charge in this question. So I'm gonna follow the palm, and the palm points into the page, and so the force here is into the page. Now for question 23, we have a negative charge, so we'll follow the back of the hand for the direction of the force. So we have B into the page. My four fingers should be pointing into the page. Okay, my thumb, which is the direction of motion of this electron or negative charge, is to the left, and I notice that the back of the hand points upward because it's a negative charge, so we'll take the back of the hand. The force is upward. Okay, so this is the magnetic field here, and this is a negative charge. This is the magnetic field here, and this is a positive charge. The magnetic field here, this is a negative charge. It's a negative charge. This is V, 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 V. It's a positive charge. It's a positive charge. V, B, B. And this is a positive charge. This is V, B, and this is V. This is a negative charge, and this is B. Alright, so let's proceed. B is down, V is to the right. So eventually my four fingers, let me adjust the camera here. Okay, so question 24, B is down and V is to the right. So I place my four fingers pointing down, my thumb to the right, and I notice this is a negative charge, so the back of the hand is pointing out of the page. So here F is out of the page. Now question 23, we have a positive charge. B is into the page, my four fingers into the page, my thumb, the direction of the charge is to the left, and so the palm is pointing downward. This is a positive charge, we follow the palm, so F is down. Now B is upward and V is to the right. My four fingers upward, my thumb to the right, this is a negative charge, so the back of the hand is pointing into the page. So here F is cross into the page. Now we have V and B are parallel, so no force here. V is to the left, B is out of the page, so V to the left and B is out of the page, so my forefingers out of the page. V to the left, this is a negative charge, so I follow the back of the hand, which points downward. The force here is down. V to the left, B is out of the page, but this is a positive charge now. Question 29. And so my palm is pointing upward. Now, V has two components here. Component parallel to the magnetic field, which does not contribute to any force, and component perpendicular to the magnetic field. So we'll follow the one going perpendicular to the magnetic field to find the direction of the force. So my thumb is down, B is to the left. This is a positive charge, so the force is into the page. And the last question here, we have a negative charge. Again here, we have two components for the velocity. One parallel to the magnetic field, this does not contribute to any force, and one perpendicular. We'll use the one that is perpendicular to the magnetic field. That's the one contributes to magnetic force. So my thumb is going to the right, B is down, and this is a negative charge, so I'll follow the back of the hand, which points into the page in this case. Alright. Okay. Now, I mentioned in one of my videos on this channel how to create such what we call, instead of the right hand rule, Salah's erasers rule. Okay, and go watch that video, and you can find how to make such a tool. It's really gonna be very helpful for you to find the directions, and I'll try to apply it for those 4 exercises which we solved, and they're very similar to the ones we solved in the paper before. So we've got here a negative charge going to the left with the magnetic field into the page. We've got here a negative charge going in this direction. This is the magnetic field. A positive charge going to the left, and in a out of the page, in an out of the page magnetic field. Now, you see on this eraser, there's the V for the direction of the charge, and it's the same for the current. There is F if the force is positive, F if the force is negative, and there's the magnetic field. Okay, now how to label them, you can watch the video and I'll show you. It shows you step by step how you will do it. Now, where to find such an eraser? In the past I bought this from Daiso, but I think you can also order that from Amazon. If you it doesn't have to be exactly the same eraser. You could use any colorful erasers of any kind, just and glue them together and make this tool for yourself. Okay, now let's find the magnetic force from here. So V is to the left, magnetic field is out of the page, so this B will point out of the page. Okay, and V is to the left, which is the pink one, so the pink to the left and B out of the page. I'll just place the eraser here. You can see V is going to the left and B, which is this one, going out of the page, and I have to look for F negative because it's negative charge. F negative here is the blue color, if you can see here. So the F negative is just pointing downward, and so that's it. F downward. That's all about it. See how easy it becomes. You don't have to twist your hand and break your hand in the process of just finding the direction. Let's go ahead and try it for another exercise here. And I'll try to bring the camera closer so that you get a better look here. So we're looking at V. V is to the left and B is into the page. So the V is the pink part, B is the orange part, and this is a negative charge, and so we'll use F negative, which is the blue color. Okay, so B is into the page, so this orange should go into the page. We'll flip it around, so now B is into the page. V is to the left, which is the pink, that's to the left, and I noticed that the blue, which is F negative, because this is the negative charge pointing upward, and that's all about it. So that's the force upward. Okay, now let's look at question 34. Again, here we have two components for the velocity. One perpendicular to the magnetic field, one parallel. The parallel does not contribute to a magnetic force, and so we'll follow the perpendicular one. Now B is down, so the orange points down. V, which is the pink, should go to the left in this case. The perpendicular part is to the left, and we're looking at a negative charge. You can see the blue, which is the negative charge force, as pointing into the page. That's about it. So F is into the page. Last one here. V is to the left, so this pink one to the left, and the V. B is out of the page, so the orange out of the page, and we're looking here at a positive charge, so we'll follow the positive force, so that's the yellow, and it points upward. That's about it. So F is upward. I hope this was very helpful for you. If you have any questions, please feel free to contact me anytime, and I really wish you all the best in your exams.